So bulk storage plants have many different parts, as you can see in this picture, courtesy of Imperial Oil here in Canada. We have a couple of different scenarios. We have a tanker truck, and in the background we have those huge storage tanks. And then, of course, in between we have to get the product from the tanker truck to those large tanks, or vice versa. And so in between we're going to have pumps and bleeders and fittings and meters and similar devices. We're going to have areas both inside and out where we have pipes under pressure. And it's our job as electricians to make sure that when we're wiring up these pumps and making terminations, rather, that we're using the right equipment, we're following the right code rules, and so on. And so the rest of this presentation, we're going to break it down into the individual areas, and hopefully that'll help you determine where you have a hazardous area. Okay, so here we have a fitting. And of course we may have to wire in this area depending on whether there's any pumps in the vicinity. And so what we're going to do is we're going to look at both inside and outside locations. We're going to start with outside locations first. So what we're going to do is we're going to drag this down here, and we're going to drag these two here, because this is going to signify where our hazardous locations are at. And so if we are outside, this sphere indicates the hazardous location that would be considered zone 2, and that goes either direction 900 mil. So 900 mil in either direction is a zone 2 in a sphere-like fashion, and then down here as well we have a zone 2 on either side, and that of course extends out 3 meters either way and upwards of 450 mil above grade. And that's considered a zone 2, and that is for outside, where of course we have adequate ventilation. So now we're going to take a look at what happens when we're inside with adequate ventilation. Now I just want to touch on that for a second, because adequate ventilation is defined by the Canadian Electrical Code by referencing a document called an API RP 505. And this is a document that's put out, I believe, by the Alberta Building Code or Canadian Building Code. And it talks about how much air, rather, has to be made available to break the concentration of hazardous gases down. And what the document essentially says is there has to be enough ventilation, if you're inside, to keep the gas-air mixture below the lower explosive limit, or lowable flammable limit. And all they're getting at is that we don't want to have, or rather we want enough air to dilute the air so that we don't have a hazard. Keeping the enough air mixed up with the gas will keep it below the lower explosive limit. The problem with not doing that is that if you don't have enough air, you have the potential for an explosion. So the zone breaks down like this. So what we have, if we have adequate ventilation inside, as according to API RP 505, then this of course is a zone 2, and we're looking at a 1.5 meter distance out towards, from the center out. So a radius of 1.5 meters. Over here we're looking at 900 millimeters. And that of course extends outwards 7.5 meters on both sides. And so of course this is also 900 millimeters. And that is zone 2. Now, the only thing that changes when we go to inside with less than adequate ventilation, in other words, we don't maybe have the proper ventilation system in place, both input and exhaust, and so that's going to affect the hazard itself. In essence, what happens is this becomes a zone 1 location. So if we can erase that out of there, same with down here. Now we're dealing with zone 1. And all because we didn't have the ability, or we didn't put in adequate ventilation. We've already addressed how we're going to deal with the hazardous locations around pumps, but clearly often in larger facilities you'll actually transfer fluids inside, from the big tanks outside. You'll have some pumps inside and transfer maybe gasoline or diesel or oil to drums or barrels. And so, like I said, we've already addressed the issue of our pumps, so we essentially are only going to look at the hazardous locations now around the drums. All we have to do to address these locations is just draw in our zone 1 and zone 2 locations. So again, we have our dome, and we're just going to use one barrel here, so we're not going to address that barrel. But if we look at the fitting and the pump on this one, again, we're back to that a radius of 900 millimeters out from center, and that's considered a zone 1. Now, folks, that goes all the way to the floor, like this. And then what we do is, outside of that, of course, we have a zone 2 location, and that zone 2 location extends outwards like so. And that comes up 450 mil from the floor, and that is a zone 2 location. It also extends up and around the zone 1 location out to 1.5 meters on either side, and again, that's a radius. So technically, if we were to draw a center here, center of that valve out 1.5 meters, this of course is a zone 2 location as well. And finally, it's important to understand that this distance over here, all the way from, again, this radius is 3 meters either direction. And just on the slide up here, I forgot an M on the 900. That's 900 millimeters, not 900 meters.
So when you're wiring in one of these areas, you're going to find that, of course, there's not just the tanks we have to worry about. There's not just the pumps and the bleeders, but we, of course, have tank-type vehicles, whether it's rail car, whether it's a truck. At the end of the day, we have hazardous areas that we have to be cautious of wherever we transfer those fluids. So a couple of those areas that we have to be aware of is going to be, if you look in the top slide here, we have to concern ourselves with this area in here. Obviously, we have multiple ports where we can load these big tanks. We also have to concern ourselves when we're dealing with a truck anywhere here and here. Now, traditionally speaking, we don't have to worry about wiring a whole lot down here, but if there's a pump on the truck that requires wiring, this is certainly something that we need to be made aware of. Now, we're going to deal with both of these, but at the end of the day, they're really the same thing. So here what I've done is I've blown up an exploded view of where they're filling on this tanker car, and we're just going to look at the sphere that tells us about our zones. So once again, we have a zone 1 location, essentially, that goes like this, and that extends in a radius either way 900 millimeters, and that we call a zone 1 location. Outside of that, of course, we have a zone 2 location, and that extends outwards to 1.5 meters either direction. Zone 2. Now, if we actually consider that these measurements are based on an open dome system. Open dome simply means that we vent the tanker itself just by opening it up. Now, the picture doesn't necessarily show that. You can see we have 3 pipes coming in there. And because I'm not aware or not sure of this tanker, one of those may be a vapor recovery system. But my hunch is that all 3 are actually transferring fluid. And therefore, this is considered an open dome where they'd have a vent just kind of somewhere on the tank that vents that gas-air mixture, and therefore these measurements would apply. However, if you are using what's called a vapor recovery system, where they would run a separate pipe out from that tanker to get rid of that excess pressure that might build up due to the gas-air mixture, then what happens is the Zone 1 location, essentially what we could do is get rid of this outside part. All we want to do is we want to just look at the center part, and that center part is no longer Zone 1. It simply becomes a Zone 2 location, extending 900 mil out.
Now, when we look at bottom loading, which is kind of an example of what we're looking at here, there is a Zone 2 location essentially all around the part where the fluid comes out. So if we draw that in here, what we're really looking at, if we did this, we have a semicircle like this, and that extends, again, we're back to that old measurement of 900 millimeters either way. Now, one other part to consider is the area down where this gentleman is standing in the picture. So essentially from that outlet point, there's also an area that extends like this, and that goes out 3 meters and comes up 450 mil from the ground. And so right below that outlet there is this is all a Zone 2 location, and that's either way here, Zone 2 and upwards, again to that sphere of 900 millimeters and down is all a Zone 2 location when we're bottom loading. So when you wire on a tank farm, you're definitely going to come across various types of tanks. One of the really big tanks you're going to come across often has what's called a floating roof. And so we have to look at the zones and classifications in this type of an install. That's what you're seeing here. This is a floating roof tank, and so really it's quite simple. Anything directly above the tank roof is a Zone 1 location. This area extends from the top of the roof to the top of the shell, which is what we're showing in here, and essentially it's this part in here. Whatever that distance is, that's considered a Zone 1 location. Outwards from there, when we go above this, we'll go 3 meters, and that goes all the way around the tank. That's 3 meters outwards from the shell is a Zone 2 location. And that again is on the floating roof type. A couple of areas we have to address when we look at the standard type of tanks that don't have a floating roof, so this is the fixed type, is we have to again look at the vent opening. And we don't have a great picture here, but hopefully you can see the very top of it. And so once again we look at the very top, and we have a sphere, and that sphere, of course, this is our Zone 1 location. That extends, of course, 1.5 meters outwards from that vent. And just to reiterate, when we're talking 1.5 meters, we're talking from the center outwards. So really, that is a radius, not a diameter. So 1.5 meters in radius out from that is that Zone 1 location. Now from there we go into, of course, a Zone 2 location, and that Zone 2 location goes like this. And it actually extends all the way down and over to the dike wall. It's important to note that inside that dike is also considered a Zone 2 location. And it actually, that Zone 2 location, I might add, is at 3 meters. And so the 3 meters all the way around the tank and to the top of the dike wall, whatever the top of that dike wall is. Now, it's important to note that the dike wall isn't necessarily going to be 3 meters. In my experience, they're a lot less than that. But the Zone 2 location does extend to the top of that dike wall. often when we're wiring above ground tanks, of course, we have to come up from underground in most cases. Now, it is important to realize that many of the liquids that we're transferring, like gasoline, have a high vapor content, and that vapor content actually has a tendency to be heavy and migrates below ground. And therefore, even though we might be ordinarily looking at, let's say this is a zone 2 location, depending on how far we are out from the pumps, right below that is not a zone 2 location where we come up with our conduits and our fittings. This is actually a zone 1 location because of the hazard that we see with particular liquids like gasoline, where it actually is more dangerous below ground than it is above ground. It's very difficult for air to mix with that gas in order to dilute it to where it's not so dangerous, and so that would be zone 1. And so whether we're coming up with conduits or over here we're looking at coming up with pipes, again, this is going to be a zone 1 location. The only way we can get that to be a zone 2 location is if we have, again, we go back to that adequate ventilation. So if we look at adequate ventilation, if there's a particular install where you're actually going to spend the money and ventilate it, then you might be able to get away with a class 2, or a zone 2 location if you have adequate ventilation. For most of the installs that most of us are going to do, more than likely we're going to simply classify that as a zone 1 and wire accordingly. The last area we're going to look at is where we have to service the tanker trucks and the tanks themselves. This one's quite simple, really. We have a zone 2 location upwards of 450 millimeters off the floor in the entire shop. Now, if you have offices attached, usually what will happen is, in order to avoid having to consider the offices as a class location, you'll run a curb before you frame the walls, and that curb will be up of 450 millimeters, which suitably cuts off the offices from the shop portion, which allows us to wire in an ordinary location.